Hello, today we're going to be covering inverse trigonometric functions. So let me give you the idea of what an inverse is, and then we'll use them to solve for unknown angles. So now, previously we have been given ratios, and then using those ratios we were able to figure out unknown lengths. Our objective was to solve right triangles, and one strategy that aided us into succeeding was that of knowing the ratios. So here we were given the ratios and we were able to find the missing length. Today we contemplate a different question. Can we also figure out the value of unknown angles? So suppose that we have a triangle, a right triangle, and we have two sides. Knowing these two sides, will we be able to find the measurement of the unknown angle? And the answer is yes. And in order to do that, we're going to need the help of something called an inverse. So let's take a look at to the idea. So suppose that we have a function such as sine x. This is our trig function sine. And what this function takes in, what you can put inside of here are angles. So we usually put angles, and then this gives us out the ratios. For example, if I put in 30 degrees into sine, we would have to calculate sine of 30. You can input that in the calculator and you're going to get the value of 0.5. If you input 45 degrees inside of sine, it's going to give you approximately 0.7. And if you put in 90 degrees into sine, you're going to get 1. Now we want a way to go backwards. Instead of inputting angles and spitting out ratios, we want to input ratios and spit out angles. So for example, let's say we had an inverse function, f inverse of x. And let's say that I put in 1 here. I'm going to put 1 inside and I should be expecting to get 90 degrees. If I put 0.7 inside of here, I should be expecting to get 45 degrees. And if I input 0.5, I should be expecting to get out 30 degrees. For an inverse function, we're going backwards. Now we're inputting ratios and expecting to get angles. And for trigonometric functions, the inverses have special names. So instead of calling it f inverse, this is the generic notation for inverse functions. We're going to give it the name sine inverse. In trigonometry, the inverse functions, we just put a -1 on top of the original name. So this is sine x, this is sine inverse. Now, before we continue on to today's lesson, I want to be a little bit more technical here. So technically, even though it's not going to be explicitly stated in each lesson, we're going to be under the assumption that we have ranges on both the angles and the ratios. For example, we're going to restrict our domain to -90 to +90 degrees. Although technically we're restricting it to 0 to 90 degrees since we're working with right triangles anyways. So we're doing a little bit better. For the ratios, we're going to restrict our range from -1 to +1. This means that here I should only be getting values within this range, and this means that here I should only be inputting values within this domain. And that's going to make our sine inverse function work nicely because we want this to be 1-to-1 and onto. And that's going to be incredibly important for the algebra trick that I'm going to show you. So again, this is not going to be explicitly stated, but these are the assumptions we're working on. So now let's take a look at some examples. So let's look at example 1. So we have a triangle, and as you can see, this time we're trying to find the missing angle theta. In our previous examples, we were trying to find the lengths, so we can already see the difference. In order to solve this problem, I'm going to first label my triangle. Remember that the side that's across your reference angle, that one's always going to get labeled as the opposite. And the side that's across your 90-degree angle, that's always going to get labeled as your hypotenuse. We weren't given any information on the adjacent side, so I'm not going to bother to label it. Now I'm going to use my useful acronym SOHCAHTOA. And for this problem, I'm going to need to use the opposite side and the hypotenuse. And the trigonometric function that uses opposite and hypotenuse is sine. So I'm going to use sine here. So we're going to use sine of the angle, which here is theta. So sine of theta is going to equal the ratio of opposite over hypotenuse, 8/12. And now I'm going to divide sine theta by 1 in order to have a proportion. And actually for this problem I don't need to actually do this because we want to isolate theta. So here, let's erase this part. So we want to isolate theta, and we notice immediately that the thing that's stopping theta from being isolated is this sine function. So what I'm going to apply here is I'm going to compose the left hand side and the right hand side by sine inverse. So here I'm going to compose sine by sine inverse. So I have sine inverse sine theta, and then that's going to be sine inverse of 8/12, or 8/12. Now again, the reason I can slide with this is because I restricted my domain and my range. So here the sine and the sine inverse, they're going to cancel each other out, and I'm succeeded with isolating theta. On the right hand side, I have this thing to calculate sine inverse of 8/12. Now on your calculators, there's a second button. So if you click second, so here, let me write this down. Click second, or here. If you click second and then press sine, then press sine, you should get this sine inverse symbol. And now just write 8 division 12 and close it. Press enter, and you should get that theta is approximately equal to 41.81. You will need to use a calculator to do the approximation. If you don't have a physical one, go on decimals and do it there. But like in the previous lesson, I want you to give me both. Give me this answer and give me that answer, because if you get this part wrong but get this part right, then that tells me that the only struggle you're having is with the technology. So again, give me both. Let's do one more example. And here we have example 2. I'm going to begin this example by first labeling my triangle, and I'm going to label the side that's across my angle of reference, the one that was given to me, which is theta. So the side across my angle is opposite. Then the side that's across my 90-degree angle, that would be my hypotenuse, but you can see that they didn't give me any information on it, so I'm not going to bother to label it. The 6, by process of elimination, has to be the adjacent side. So now I'm going to get my acronym, SOHCAHTOA, and here I realize that I'm going to need to work with the opposite and the adjacent. So the opposite and the adjacent is screaming at me to use tangent. So I'm going to get tangent of my angle of reference, which is theta here. Tangent of theta is going to be the opposite, the ratio of opposite over adjacent, so 4/6. And as you can see here, my tangent of theta is already pretty much isolated, so I don't need to do any algebra. I don't need the proportion here to help me. So what I'm going to do here is I got to get rid of this tangent by multiplying, by composing the left and the right by tangent inverse. So I have tangent inverse tangent theta on the left hand side, and then I have tan inverse of 4/6. So tangent inverse and tangent, those are inverses, so when we compose them we just get 1. So we get 1 times theta equals tan inverse of 4/6. 1 times theta is theta, and inputting tan inverse of 4/6 in the calculator, I'm getting an approximation of I'm getting about 33.69. Now go ahead and do the rest of the assignments, and again, if you need extra help, just message me, and attend Zoom office hours.